Inequalities and absolute values. Okay, it's the absolute value. It is either positive or negative, no in between. Can't be negative because I'm only caring about the value of the number, not whether it is positive or negative. The absolute value of 3x plus 5 is less than or equal to 17 means 3x plus 5 is either less than 17 or less than negative 17. So we solve it and take them out of the absolute value part. One side. Mm, 22. Yep. So how do I write the answer? The set that includes negative 22 over 3 up until 4. Absolute value of 2x plus 3 less than 5 is the absolute value of 2x plus 3 either less than 5. Actually, this is not less than or equal, so it's just less than. So it's a little different. That means 2x plus 3 is between 5 and negative 5. So I solve one side. Negative 5 less than 2x plus 3. Switch it around so it looks normaler. So I want my open side to be with my x. And I'll do this side. X is less than 1. So I write my answer, I put these together. Okay, X is less than 1. Got that from here. And it's also greater than -4. After the value of 3x plus 3/5, this whole thing, greater than or equal to 3. So I put my 3x plus 3/5 greater than or equal to 3, which is less than or equal to -3. Solve them. Solve one of them over here. This is over 1. How do you want to do this? I'm going to just multiply the whole thing by 5 so that I get the same number on the bottom, or a new number on the bottom. So -15 is greater than or equal to 3x plus 3. -6 greater than or equal to x. Right? Yeah, that's -3. Yeah. That's this side. And the other side is this. 3x plus 3/5 greater than equal to 3. Same thing, I'm going to multiply by 5/1. 15. So I have this down to -6 greater than or equal to x, and x is greater than or equal to 4. So I can write it like this. And if I had to put it on a number line, all the magic is between -6 and 4. So I'll go by 2's on my number line to make it easier. X is greater than or equal to 4, greater than or equal 4, and X is less than or equal, I colored in, to -6. I can also write it as, since it's an or and not an and, it goes from negative infinity all the way up until -6, including -6. Or it goes from 4, including the 4, so it gets a hard bracket, all the way to infinity. Infinity always gets the open bracket because there is no end and it cannot be included. Okay. Let me give you a few little, not rules, but things. Okay, when you have the absolute value equal to a constant, that's the same thing as, it's either that number or it's the opposite of that number. When you have the absolute value less than a constant, it's between that constant. It's between -c and c, the constant. Absolute value less than or equal, it's the same thing. Negative part and the positive part. But if you have this square root of value equal to another square root of value, what the heck? Then they have to be equal to each other. Okay, so let's I'm going to rewrite it as the 3x minus 1 in between 5 and -5. And then I solve one side. And I solve the other side. My number line, what's it looking like on my number line? Number line, I have -1 1/3. I'm just going to say -2. -1, 0, 1, and 2. So I have -1 1/3. About here. X is less than that. Does not include it, so I'm going to leave this circle open. And on the other side, x is greater than 2, not equal to it. So I'll leave the circle open as well. All the stuff is here. I could write it as x, no, I can't, because it's not between, it's an or. If it's an or, it's one or the other, not a between situation. Absolute value of 2x plus 7 minus 3 less than or equal to 9. First thing I'm going to do is I like to have all my stuff on one side. So only my absolute value I will have over here. I'm going to move away this nosy minus 3. And I want to have just the constant on the other side. Oops. X plus 7 less than or equal to 12. And now I'm going to rewrite it as 2x plus 7 less than or equal to 12 and also greater than or equal to minus 12. So this side oops, I keep doing that. Negative 19 halves. And the other side. And 8 and 10 and 12, 5. X is less than or equal to 5 halves. What about these numbers? Well, let's see. Now we're on a number line. And this is minus 9.5. And this is 2.5. So I'm going to go from minus 10. Nope, just made it. And I have x is less than or equal to 2.5. So about here. Less than or equal. So I'm going to color it in. Color it in. Which means when I write it with the brackets, it gets a hard bracket because it includes 2.5. And then x is greater than or equal to 9.5. Negative 9.5, sorry. Greater than or equal to negative 9.5. So I can put it in set notation all the way from minus 9.5 to 4. I can write it as including the minus 9.5 all the way to 4 and up to and including the 4.